that our substitution skills may be a little shaky. We really haven't used substitution for probably a couple weeks because of the material we've been covering in addition to our force notice. Okay? So today what we are going to do is we're going to get back in the swing of things as far as substitution is concerned, but we're going to go ahead and look at the definite integrals that have u substitution involved. Okay, so go ahead and write this down. Okay, the u substitution process does not change when we have a definite versus indefinite integral. Okay, what's going to change is what you do when you plug the numbers in. Okay, and I'll show you what I mean by that. So we can either multiply this out 5 times. No thanks. Or we can let u equal x squared plus 1 because that's what is inside of our function, of our composite, which means du is 2x dx. Do we have 2x dx? We do. So 2x dx gets replaced with du, and x squared plus 1 becomes u. Okay. Now, we are going to keep the limits of integration off for a moment, okay? Because those limits of integration are for x, and we've changed everything to u. Okay? So, what we're going to do is this becomes u to the 6th times 1/6 plus c. Do you agree? Okay. Do we need the plus c? No, because we have a definite integral, don't we? Okay, so we can change it back to 1/6 x squared plus 1 to the 5th. And since we're doing a definite integral, we're going to need to evaluate that from 1 to 3. Yep. I saw confused looks. There we go. I was looking at the wrong line when I wrote it down. Okay. So now we have 1/6 3 squared plus 1 to the 6th minus 1/6 1 squared plus 1 to the 6th. You're definitely going to need your calculators to help you evaluate this, so go ahead and do that. It's a pretty large number, I would imagine, since we have 10 to the 6th there. Is it a 6-digit number? All right, what is it then? Go ahead and math 9 that original problem and make sure that math 9 gives us 166,656. Are we right? Okay. Questions over this problem? Now, here when I did the u substitution, I went ahead and did it as an indefinite integral and then switched it back to a definite integral once we switched it back to x's. Okay? There's a different way we could go about doing this. And I'm going to show you what that looks like in our next problem. Why are you whining? Oh, wait, this is the same problem, isn't it? Sorry, I thought it was different. It's the same. Okay, so we let u equal x squared plus 1, and du was 2x dx. Yes?
How do you put 2x in there? I was trying to figure it out.
Oh, so if you do math now, from 1 to 3, you would write 2x. Okay, so you would have to do new parentheses. X squared plus 1 to the 5th. And then, yeah. All right, so now what we can do when we switch to u's is we can keep it as a definite integral. So this would become u to the 5th du. Okay? We're going to have to plug our values in no matter what. So what we can do is we can make it simpler in this step and go ahead and change our limits of integration. So these limits of integration represent the x values. Okay? Well, now that we have an integral with u's, we can change our limits of integration to be u's instead of x's. So if x squared is 3, what would u equal? If x is 1, what would u equal? Okay. So now we have an integral involving u, but we've changed our limits of integration to be in terms of u. So now we don't have to worry about going back to x. Now what we can do is we can take the antiderivative to be 1/6 u to the 6th and evaluate that from 2 to 10. I would say that it's about the same amount of work either way. It's all going to depend on maybe how your brain fits it all together. Okay? You may want to change your limits of integration to u, and so then you don't have to worry about going back to x. Your brain may really like that. Okay? It is not a problem if you want to do it this way. Do your u substitution with what looks like an indefinite integral, and then switch it back to x's to use your original limits of integration. I don't care what you do, but you have to be consistent either way. If you're going to use 1 and 3, you have to get back to your x's. If you don't want to worry about that, change your limits of integration to be used. So I just want you to kind of think about which method you would maybe like better as you write down this problem right here. And then turn to your neighbor and tell them which method you think you're going to do, or you would want to do. Keep them as u's, or change the u's, or keep them as x's. What? Okay, that wasn't what I was asking you to determine. We're going to use u substitution no matter what. So how many of you want to use u substitution and change the limits of integration?
That's the second option.
That's the second option. How many of you want to do U substitution but change back to x's so we can keep 1 and 3? You don't have to know. Okay? No matter what, our first step is going to be this. U equals what? 4x cubed plus 1, which means du is 12x squared dx.
Yep.
You're not seeing it? Well, but there is x squared dx, right? Okay. We do have x squared dx. So what do we have to do with that 12? Divide it over, move it to the front. So, if you're going to do the first method we did, you have the integral, you have 1/12 the integral of u to the 4th du. If you're going to do the second method that we just talked about, what would your limits of integration change to? Instead of x is 1, we would have u equals 5. Instead of x is 3, u would be
09.
Okay. No matter what, this becomes u to the 5th times 1/5, but it's times 1/12, so that would be 1/60th. Yeah. Okay. So over here we would need to change it to 1/60th times 4x cubed plus 1 to the 5th, so that we could evaluate from 1 to 3. So you have this is going to be a ridiculous answer, isn't it? You're going to need to use your calculator. All right. Emma, you have yours. You have your calculator out. Do you have an answer? Just start spouting off digits.
2, 5, 6, 4, 3, 7, 2, 7, 3.7.
Yeah, that's what I got.
I can calculate today.
What is that? 5, 6, 4, 3, 7, 1, 2, 7, 3, 4, 5, 6, 47.
Write a problem and to get an answer of that, and I would be impressed. Okay, so you see it's the same amount of work either way, because either you're doing more work to set up your problem, or you're doing more work when you switch and plug in right here. No matter what, you're plugging those x values into the u function. Okay, so it's the same amount of work either way. It's more about how does your brain process things, what's going to be helpful for you. I'll accept either method. Okay? Did you have a question? Or you just okay. This one I want you to do by yourself. Please. Now, you can turn to your neighbors and ask for assistance. I don't mind that. But basically, you're doing this without. What are you doing?
You do. Could be a way to go.
But I would say using the 1/2 power would be advisable. You should get an extremely small number. Three decimal places.
The problem is, what if you never do like work and I have time and you just sit there and be like,
This is.
They don't take that long.
because sometimes you just think you do things right and you
Should be getting 0.609.
Oh,
Did you know
gosh.
U equals x squared plus 1. So du equals 2x dx. You should have 1/2 the integral of u to the 1/2 du. Yeah?
Yep.
So u to the 3/2 times 2/3, so you end up with 1/3.
Yep.
Okay. Did you
Oh. Hold on.
Anybody else need to find a mistake?
Change my exponents just for no reason at all.
Okay. No one else?
Wait, can you help me?
Yeah.
9.
So you would want to put in x parentheses x squared plus 1 in parentheses 2.
Yeah. But I know I'm like. What if I did my math wrong?
All right. One last thing. Average value. The average value of a function is 1 over b minus a times the integral from a to b of f of x dx.
So do you start thinking and then just
You do everything normal and then you divide it by b minus a. That is correct. Okay? Let's talk about why this makes sense. When you are finding the integral from a to b of f of x dx. You're finding the area, okay? Well, if you divide it by b over a, you're basically dividing it by the width, okay? So what you're going to get out of it is its average height, okay? So you have the area, you divide it by its width. It's not going to be a solid shape, right? It's going to be curvy. But what you get out of it would be its average height, okay? So which average y value do we have over the course of this interval? Okay, kind of give you a picture. Here's a curve from A to B. When we take the integral, we're going to get this area. So when we divide it by the width, A minus B, what we're going to get out of it is this mystery number right here. What's the average height? Okay. So let's do an example. Okay. So in your notes, write average value of f of x equals 3x squared minus 2x from 1 to 3. And this will be how we finish our notes. So hang in there. It's actually gone fast today. I looked at the clock and I was like, oh, we're almost done. Time flies when you're having fun.
That's right.
More fun than
Love some new substitution.
watching that boring Super Bowl last night.
It was a rough game.
It was long.
Jesus Christ, the guy's coming out of his He's a stud.
Do you see that commercial?
Yes,
Where he was
I
like,
did.
hold my rings.
I hate it. He's self-aware.
All right, so average value. 1 over b minus a
Hate him because you hate him.
times the integral from 1 to 3 of whatever our function is. Okay? The only thing that changes is that we have a coefficient out in front of our integral. Okay? So that coefficient is going to be 1/2. Now when we take our antiderivative, oh, this is nice. What's our antiderivative?
X cubed minus X.
It's like the best antiderivative ever. Okay? Okay, so we still have that 1/2 out in front. So we have, what, 27 minus 9 minus 1 minus 1, right?
Nine.
So our average value is 9. Okay. Now, what if I asked you for the x value that occurs at? Okay, if I'm asking you for the x value, this is what's considered a y value, right? So if I wanted the x value that it occurs at, we would have 3x squared minus 2x equal to 9. Or, well, it's not going to be a nice number, is it? Or you can do, you could graph this and graph this and find where they intersect. or the quadratic formula, either way.
We will do the graphic.
You're gonna do the graphing one? X equals negative b.
Oh, we're in a weird Zoom.
2.097? That's what you got? It happens in two places, but there's probably only one in our interval. Okay, so you'll notice that your homework comes from two different pages, I think. So am I remembering that correctly? Okay, one is for the U substitution practice, and then one is for the average value practice. Okay? If I remember right, your assignment is not very long. Okay? Now, I did tell you I'd make it up to you that I gave you 2 assignments over the weekend. It'd help if you'd actually do those 2 assignments. There was a handful of people who didn't do the 2 assignments. So I can't really make it up to you if you don't do your homework.
Not do their homework.
Well, if you did the quadratic formula.
Well, to be fair, I did do 2 assignments this weekend. And to be fair, I thought I did 3.
Intersect. And then you need to like
Whoa, buddy.
Are we?